Welcome to No Family. In today's lecture, we are solving out the question related to double integral that is directly used in the Couette flow and in other derivations in MSc and BTech and BSc questions. The question says that evaluate 0 to 2 pi, 0 to 2 pi double integration given and the determinant is given sin t1 minus sin t1, sin t1 minus sin t2, sin t2 minus sin t1 and sin t2 minus sin t2. Here sin t1 minus sin t1 and sin t2 minus sin t2 is cancelled out, that become the 0. We can write down solution. At first write down let I is equal to let I is equal to integration 0 to 2 pi 0 to 2 pi double integral is given 0 to 2 pi and it's become sin t1 minus sin t1 is 0, sin t1 minus sin t2 becomes sin t1 minus sin t2 sin t2, sin t2 minus sin t1 sin t2 minus sin t1 sin t2 minus sin t2 0 and d1 d2 with respect to the integration of d1 dt1 dt2 dt2. Now we solve out, then we get I is equal to, we know that if the determinant is given AB BC, then we can multiply 0 to 0 minus sin t1 minus sin t2 into sin t2 minus sin t1. So I is equal to, it's become 0 to 2 pi as it is 0 to 2 pi 0 to 2 pi again 0 to 2 pi 0 to 2 pi. When we multiply, first of all multiplied 0 to 0, then 0 minus sin t1 minus sin t2 sin t1 minus sin t2 into sin t2 minus sin t1 sin t2 minus sin t1 and that's multiply by dt1 d2 dt1 dt2 with respect to dt1 dt2. Now we solve out and get the solution, then we get I is equal to 0 to 2 pi as it is, so write down 0 to 2 pi and again 0 to 2 pi. Now take out a minus as a common, minus minus plus it's become sin t1 minus sin t2 into sin t1 minus sin t2. We know that a minus b the whole square is equal to a square plus b square minus 2ab, so it's become sin t1 the square sin t1 the square plus sin square t2 minus 2 sin t1 sin t2. It's become 2 sin t1 sin t2 into dt1 dt2 into dt1 dt2. Now we can write down the separate and after then carried out the integration with respect to dt2. When we carried out the with respect to dt2, we get I is equal to 0 to 2 pi as it is. Write down 0 to 2 pi as it is 0 to 2 pi. When we carried out the integration with respect to dt2, then sin square t1 is constant, so write down sin square t1 Sin square t1 is a constant, and when we carried out the integration with respect to dt2, then the dt2's integration is always t2, so t2. Put the value 0 to 2 pi, so write down 0 to 2 pi. When we carried out the integration with respect to sin square t2, so it's plus integration with respect to 0 to 2 pi. We know that cos square theta is equal to 1 minus 2 sin square theta. 1 minus 2 sin square theta. So it's become 1 minus cos 2t2 upon 2 into dt2. When we carried out the other c, then minus 2 as it is, sin t1 as a constant because we carried out the integration with respect to t2, then sin t1 as it is, integration with respect to t2, so 0 to 2 pi sin t2 into dt2 with respect to dt2 into dt1. Now we solve out this, then we get I is equal to I is equal to 0 to 2 pi as it is, so write down 0 to 2 pi. When we put the value, then we get, first of all write down the upper value, after then lower limit, sin square t1, it's become 2 pi minus 0, so 2 pi minus 0, so write down 2 pi minus 0. After then solve out, then we get 1 by 2. When we carried out the separate divide, then 1 by 2 minus cos t2 upon 2. Then we can solve out 1 by 2 as it is, so 1 by 2 as it is. 1 by 2 as it is. The integration of dt2 is t2, so t2. Value of 0 to 2 pi, so write down 0 to 2 pi. The integration of cos 2 theta is equal to 1 by 2 sin 2 theta. So it's write down 1 by 2 into 1 by 2 is 1 by 4. So minus 1 by 4 sin 2 t2 to t2. Put the value 0 to 2 pi. So 0 to 2 pi. Write down 0 to 2 pi. After then minus the integration of sin theta is equal to minus cos theta, so it's become minus plus, so plus 2 sin t1 the integration of sin theta is equal to minus cos theta minus plus, so it's become cos t2 limit 0 to 2 pi, 0 to 2 pi, bracket close, and into dt1, so write down dt1. Now we solve out the values, then we get I is equal to integration 0 to 2 pi, write down integration 0 to 2 pi. When we carried out the multiplication, it's become 2 pi sin square t1, 2 pi sin square t1. Carried out the multiplication. When sin square t1 multiply by 0, it's 0. Now write down plus 1 by 2 and pi 2 pi, so it's become plus pi, plus 1 by 2, it's t2, so 2 pi minus 0, so it's write down 2 pi, minus 1 by 4 as it is. When we put 2 pi, so sin 2 into 2 pi, that is 4 pi. The sine 4 pi is 0, so sine 4 pi is 0, minus sine 0 is always 0, so minus 0, plus 2 sine t1, write down 2 sine t1. When we put 2 pi, cos 2 pi is always cos pi is equal to minus 1, cos pi plus pi in the second quadrant, so cos 2 pi, write down cos 2 pi, cos 2 pi, see the values, cos 2 pi, cos 2 pi stands for cos 0, cos 2 pi stands for cos 360 cos 0. The value of cos 0 is always 1. The value of cos 0 is always 1. So write down 1 minus 1. So write down 1 minus 1. Cos 2 pi is 1. Cos 0 is also 1. So 1 minus 1 into dt1. Write down into dt1. When we solve out, we get the values as a I is equal to 2 pi as it is outside because it's a constant, 0 to 2 pi integration, so write down 0 to 2 pi, sin square t1 as it is, so sin square t1 into dt1. The integration of pi, so 2 cancel out, pi as it is 0 to 2 pi, 0 to 2 pi dt1, so write down dt1, 0 to 2 pi dt1. Next one is minus 1 by 4, it's 0. 2 sin t1, 1 minus 1, it's also 0. Now we solve out by the integration, so we can write down, we know that cos 2 theta is equal to 1 minus 2 sin square theta, 1 minus 2 sin square theta. So when we put the value, we get I is equal to 2 pi as it is, and it's become 0 to 2 pi. Sin square t1 can be written as 1 minus cos 2 t1, 1 minus cos 2 t1 upon 2 into dt1 plus pi as it is. The integration of dt1 is always t1, so t1 0 to 2 pi, the limit is 0 to 2 pi, Now we solve out and get the solution. So I is equal to write down the separate 2 pi as it is, integration 0 to 2 pi, 1 by 2 take out the common, then 1 by 2 outside, and it's become dt1 minus 2 pi upon 2 0 to 2 pi cos 2 t1 dt1, cos 2 t1 dt1, write down dt1 plus put the value, then pi 2 pi minus 0, it's a definite integral, so not to write down the constants plus c. So I is equal to 2 pi as it is, the integration of dt1 is always t1. So put the value of t1 0 to 2 pi, 0 to 2 pi minus pi as it is. We know that the integration of cos 2 theta is equal to sin 2 theta upon 2. So write down pi by 2 sin 2 theta. So here sin 2 t1 0 to 2 pi, 0 to 2 pi plus 2 pi square, 2 pi square. Now carried out the solution, carried out the multiplication of the terms and find out the solution. Then I is equal to pi as it is, write down 2 pi minus 0, 2 pi minus 0 plus pi by minus pi by 2 as it is, so minus pi by 2. Put the value of 2 pi, so sin 4 pi minus sin 0. The sin 4 pi is equal to sin 720, that's value is always 0, so sin 0 minus 0 is always 0, and it's a 2 pi square. Now it's become I is equal to 2 pi square, 2 pi square. The sin 4 pi is 0 and sin 0 is also 0, so 2 pi square plus 2 pi square. So the final solution is I is equal to 4 pi square. I is equal to 4 pi square. In the MSc and MTech books, the Couette flow having the direct values of I is equal to 4 pi square, where we are using the double integral and the value is put I is equal to 4 pi square direct. When the integration, double integration is given sin t1 minus sin t1 into sin t1 minus sin t2 upon sin t2 minus sin t1, sin t2 minus sin t1. Then we can at first solve out the determinant. After then, using the properties of the integration, we can solve out the question and get the value, that is I is equal to 4 pi square. If you have any problem in this question, then you can also solve the doubts on my YouTube channel and by mail. Now our lecture is finished. Jai Hind, Jai Bharat.